Hi, I'm Dion from LegalCertMathsVideos.com. Now, the first part of my introduction video of differentiation showed us how to find the slope of an x squared diagram using first principles. Before I was using y2 minus y1 over xy equals x1, but you're eventually going to have to get using this formula here if you want to differentiate more complicated functions from first principles. This is a general formula to use, okay? The limit as h tends to 0 of f of x plus h minus s of x would just be y2 minus y1 all over x2 minus x1. But when you subtract these two always, you're just going to be left with h to the bottom. So that's just a better formula for it. Okay? So just a quick recap of what we done last time. We want to find the slope at the point x here, okay? So y2 minus y1 all over x2 minus x1, which gave us the slope of this tangent here. We want the slope, obviously, of this tangent. What we've done first was, we found the slope of this tangent here, okay? We found it in terms of h. And then we left h equal to 0, because the smaller h is, the more this tangent kind of shrinks downwards and downwards, the more this point moves along the line here, the smaller h is. Sorry, move that line. The smaller h is, the more that tangent moves along the line, okay? So when h is equal to 0, you actually get the tangent at the point x at h is equal to 0, okay? So the slope of a function is the limit of h equals to 0 of this function here, okay? So now we're going to go on to more complicated functions, okay? So if we have y equals to x cubed. Now I'm not going to prove this, okay? I'm not going to prove this because it's just a waste of time. You don't have to know for, well, most of you should have to know for your exams. Okay, now the slope of this function is 3x squared, okay? So I'm just going to show you the rule. This is one of your first rules. If y is equal to nx, or x to the power of n, then dy dx is equal to n times x to the power of n minus 1. Okay, so just do a quick example of that. If y is equal to x cubed, dy dx is equal to 3x squared, okay? And I'll do one more example, a more complicated one. If y was equal to 3x to the power of 4, okay, dy dx, remember your formula here, you bring the term down, okay, so it's 3 times 4, all to the power of x, and we reduce the power by 1, which is 3. So the answer is 12x cubed. dy dx is equal to 12x cubed. Okay, so that gives us a general formula there for dy dx from x to the power of n. Dy dx is n times x to the power of n minus 1. And if we got a term here in front of x, if y is equal to, say, ax to the power of n, then dy dx equals n a times x to the power of n minus 1, okay? So then you'll be able to differentiate functions like this when you have an x cubed and x squared term. But also, again, you can prove it, but it's very long, it's kind of unnecessary. If we had a function y equals 2x cubed plus 4x plus 6, okay? We're going to do this one now. We want to get the function of this. We differentiate each one of them separately, okay? So dy dx is equal to, bring the 3 down in front, okay? So 3 times 2 is 6, and then we reduce the power by 1, so 6x squared. And then we have 4 to the power of x minus 1. I'll just rewrite that. 4 to the power of x to the power of 1. That's basically what it is. So 4 times 1 is just 4. And x, you reduce the power, x to the power of 0 is equal to 1, which means we're just basically just plus 4. And then we have a 6 on the end. And the real term constant is always 0, okay? That is plus 0. I'll just leave that in the end so you'll understand. So basically we just brought the 3 down. 3 times 2 is 6, reduced by the power of 1, so it's 6x squared plus 4x. When we differentiate any number here like ax, we differentiate that, we're just going to get a. We differentiate 10x, we're just going to get 10, okay? When you differentiate constant, we get the 0, okay? Now, I'm going to explain why we're going to differentiate the constant to get to 0, and then I'm going to move on to complicated rules in my next videos. When we go, we have a graph here, okay? It's y equals x squared. Okay, and we're going to have a line here. We're going to have a graph here, okay? Now, that's equal to y equals x squared, we call that plus 0. Okay, Okay, now when we have this say tangent at the point x, the slope of that is going to be the very same as the slope of the line y equals x squared plus 4. Okay, so we have intercept here at 4. So hopefully I'll draw this right. Now, if we have the slope of this line here at the point x, the slope of that is going to be parallel, it's going to be the exact same. So basically our slope is going to be the exact same as what our intercept is here. Intercept here is 4, it's constant. So if our intercept was 20, it'd be up high. If it was like -4, we'll do a -4 one here. Or do we call it like -6 actually? Y equals x squared minus 6, okay? The slope of this x function here is going to be the exact same, okay? So basically the slope of the line is going to be the same where we are. If you know your graph, you should be okay with this. Because the number is just the intercept basically tells you how high or low the graph is. And the graph is the exact same slope from where we are, it's the exact same up or down. So where that's minus a billion, it's going to be the exact same slope here, it's going to be down further, okay? So next, check out my chain rule videos, my coaching rule videos, and more advanced differentiation as well. Thanks for watching.